All right, so good morning. Thanks for the intro, Julie. My name is Kaitlin Moore. That's right, Julie just sort of gave a bio of me. So thanks for that. Today I'll be outlining SRI's capabilities in quantum fabrication and prototyping. So what you kind of see there, the image is of one of our unique prototyping capabilities, actually, which is a miniature vacuum chamber employing a magnet-free ion pump. So I'll have a slide on that a little bit later. But so as you'll see, many of our offerings are sort of revolve around hardware and componentry, specifically developed for neutral atom quantum sensing and some related platforms. And so that sort of makes this presentation maybe a little bit different from the others. But nonetheless, SRI is sort of an independent, mission-driven nonprofit, founded in 1946 by Stanford and sort of divested, became independent later on back in the 70s. And since then, it's acquired the Sarnoff Corporation, which was formerly RCA Labs, and then more recently our friends at Park, so the Palo Alto Research Center, formerly of Xerox. So through that, we've, sort of built up a nice backlog of history and capability in advanced R&D. So we do R&D engagement in several ways, including licensing, some commercial contracts, quite a bit of federal funding, actually, funding through federal contracts. And sort of through these, we can collaborate with partners. I'm happy to collaborate with partners. So our capabilities span from sort of biological and education research through to more hardware-based and microsystems R&D. And so, of course, here today, I'll focus on capabilities we've developed relevant to the quantum community and specifically relevant to integrated quantum sensing platforms. So first, I want to start sort of generally by outlining our foundry type capabilities, which are sort of specifically relevant to the optical devices found in quantum sensing and related hardware. For example, we have some sort of full wafer fabrication clean rooms. We have, staff with 20 plus years in custom high fidelity epitaxial growth. Fabricate on wafers up to 6 inches in diameter. Some nice material sets listed here as well. And, we can also, achieve some high quality superlattices as thin as a nanometer. Some layer thicknesses, over 10 microns is listed there. Show a nice picture on the right there of one of the superlattices, 3.5 superlattices. And, if folks want to sort of read more about that, you can sort of visit the website link here. We also have our group lead for that effort on the line as well on the panel today, available for questions. Some sorts of device types include DFBs, VCSELs, and QCLs, as well as some APDs, pin photodiodes, and optical modulators. So the offering there is mainly sort of a foundry type offering with sort of custom MOCVD growth, and it's mainly contract based. Okay. So next, I want to highlight some of our photonic integrated circuit capabilities. We have expertise that includes sort of a PIC design, layout, and test capabilities, and this sort of spans a variety of platforms, wavelengths, and applications, some of which are shown here. For example, there's a nice, we have a nice sort of single frequency violet wavelength integrated 3N chip laser. It's sort of shown in the bottom right-hand corner there with a paper reference if anybody's interested. That's sort of a nice sort of heterogeneously integrated system on a PIC at a wavelength that could be relevant for something like a strontium ion, for example. And as well, we have, expertise in some quantum networking applications and optical phased arrays. But what our sort of atomic sensing group sort of most closely works with the PIC group on is some near IR waveguide platforms, including silicon nitride, for example, and some other material sets listed there, because we tend to target these sort of nice sort of ground state neutral atom wavelengths, 780 nanometers being one of them. And we, can design for and also achieve both in-house and foundry fabrication as well. Capability to partner with several different foundries. So our, the offering here is mainly collaborative through a contract, and then I would, certainly contact Dr. Kale Gentry or Dr. Thomas Winter, whose contacts are at the bottom of the screen there for more information. Great. And then finally, I'd like to dive into our anodic bonding prototype capabilities, which are, fairly unique, nice offering, I think, in the community. These sort of three-dimensional anodically bonded vacuum enclosures for neutral atom or related platforms. The expertise here includes design and assembly capabilities for complex platforms, including silicon and glass vacuum enclosures and robust optics photonics or even electronic feed-through integration. You can see some, example pictures on the right-hand side there. We have, this nice enclosure that is sort of an epoxy-free vacuum cell construction for compact cold atom applications. We have a member on staff who's been doing this for about, for over 15 years, sort of assembling these sort of custom anodically bonded prototypes. As well as shown in the sort of upper left-hand photo there, image there is sort of an image of an integrated magnet-free mini ion pump, which is a sort of a unique offering here as well. And then finally, recently we've achieved epoxy-free photonic circuit vacuum integration, which can also be sort of a hybrid magnetic photonic chip vacuum integration, also achieved via anodic bonding. And we have several pictures kind of shown, well, two different pictures rather shown on the slide here of that as well. If folks have questions on that, I would certainly contact Dr. Sterling McBride, listed on the bottom there. I mean, I can also answer some questions as well. And here the offering again is mainly, similar to our photonic offering, which is more of a sort of collaborative under a contract kind of partnership. Okay, so with that, I'd like to thank you. Sort of an overall contact for any of this could be Greg Smith, who's our business development liaison at this email shown here.